Hello and welcome back, guys. In our last video you gave your first step to become a software engineer. If you still haven't seen it, I'm gonna link it right here. And I understand that was a long video, there was way too much of me talking. I promise you that was only the first one. For the next ones it's gonna be much more focused on coding, including this video right now. So after our last video, you were able to install the Java compiler, to have IntelliJ correctly installed, and you were able to run your first very simple codes. So now we are going to start with the basics of Java. For this video, basically what I'm going to do is to give an overview of the Java compiler. How does that work? How can you compile things manually? I'm gonna go briefly about Java primitive types, of the Java variables, and basics of string class. So without further ado, I don't want to keep you guys looking at me so much. Let's go for the code. See you later. Okay, so we are back to our code. Just one thing that I wanted to make clear before we go into the variables and all the Java basics. I just want to explain you guys how does the Java compiler works. So we are using this tool, right? So we can type our code, but you don't need that to work with Java. So let me show you something. So if we just gonna copy everything here, okay, I'm going to create a new file in any folder, okay, new text. I'm gonna call it hello.java. So basically what I'm going to do is I'm going to create the same software that we created there. So I just pasted. So same thing, public class hello, public static void main, my first Java code. Okay, I'm gonna save this. It's saved. Once I open my command prompt, okay, we can see my Java file created here. So when we are in IntelliJ and we hit the play button, so what does it do when you hit play? It compiles that file and it executes it. Again, this is just a tool. How do you do that manually? So we have our file here, hello.java. If I type Java C, that stands for Java compiler, and hello.java and hit enter. And then you can see we have a hello.class file. So let's open that class. Let's see what's in there. You can't understand anything here, right? Because this is what we call bytecode. And the bytecode is the executable file that the JVM can read. If we type Java hello, my first Java code. So this is what happens when you are working with IntelliJ. When you do some changes here and you save and you click run, it runs the Java C, it compiles, generates the bytecode and executes. Okay, I just want to show you guys this once because every Java developer needs to know how to do this, but we are not going to do this. In my 20 years, almost 20 years of experience, I have never needed to develop a full system like this. Every now and then you have to go there and execute something manual, especially if you're working with containers, but that's it. You don't really use this on real life, but it's something that you must know, okay? Okay, so let's start with something called variables. What are variables in Java? So every time you're developing a piece of code, every now and then you're going to need to store values. Any kind of values, maybe a name, maybe an age, maybe a date, anything. And how do you do that? You store that value in a memory, inside a variable. So let's say that you need to write a code that you store the age of the user. So you can type int age equals 25. Never forget the semicolon here. So how can we use that? How can we print that? Remember that we had the system.out.println, right? You don't have to manually type that. Again, as we are using IntelliJ, this is a tool to help us. If you start to type S, it already shows system here. You hit enter. Once you click on the dot, it shows all the other options. We need the out and the print. So you just hit enter. You see that it already added the parentheses and also added the semicolon here. So those are the kind of things that IntelliJ does. If you really want to be productive, what you're gonna do is you're just gonna type
out. You see, prints a string to the system out. So you just need to type out and hit enter. Ah, even better, right? So if I type, if I type system out println and age and hit play, 25. Okay. Remember that before we had a message, we can even aggregate those two things. So your age is, and then we hit play again, your age is 25. So what does exactly int means? That is short for integer. What is integer? So integer is a primitive type variable. Java has a few primitive types and I will show you them. So for example, we can store numbers in Java primitive types. Which options do we have? We have all of those: byte, short, int, long, float, and double. From byte all the way to long, we are storing full numbers. We are not storing things with a decimal digit. If we want that, we need to use double or float. So why would you use byte and not integer, or a long and not a short? Basically, it's about the size of a variable. So if you want to store something like an age of a person and you set that as a byte, maybe that's not the best idea, because if the person gets 128 years, well, first he's a Highlander or something, but that can happen. And if that happens, then you're gonna have a problem. If you try to set a variable byte with 128, for example, it's gonna break. How can we be sure of that? Let's change this to byte. If I put 127, it works. If I put 128, you see, there's an error. What I put here? It says, hey, you provided an integer, because it knows that 128 can't fit into a byte. If I put 127, it works. So then you might think, yes, let's always use a long, for example, because a long, look at the size of this number. I didn't even know how to say this number. It is 90 quintillion. So that's a number followed by 18 other numbers. So this is a minus 90 quintillion to plus 90 quintillion. So you think, hey, yeah, let's just do this, right? Then we have no problem. I can put as long as I want. Yes, you're correct. But when you use long, you can see the size of the number that it can store. That takes up much more memory than a byte. When you are developing, you should always think about memory, right? You don't want to add unnecessary information to the memory. I'm gonna share on the links on the description, so you can understand exactly how many bytes a byte gets. So in this case, a byte takes 1 byte, a short takes 2 bytes, an integer takes 4 bytes, a long takes 8 bytes. You have to think about memory. Don't create everything as long, because that will take much more memory than it should. So just check the link in the description. That's the official Java documentation. It goes a little bit more deep and it shows exactly how many bytes and what kind of things you should use. Okay, so from byte to long. For floats and double, that's the difference between those ones, that you can use a decimal digit. So if you want to store someone's weight, for example, there are decimals in that. So you need to use either a float or a double. The difference between double and float is that double goes up to 15 decimal digits and float up to 7 decimal digits. So when you're developing your software, you need to remember who's going to use that and what kind of values are going to store. If you need something with high precision, you're probably going to use a double. If a high precision is not necessary, then you're going to use a float. So when we're talking about primitive variables, numbers are the ones that have the biggest choices. Next one will be characters. There's only one primitive variable that can use it, and it's called char. Char can always store one single value, so either A or B or C or whatever. It's just one character and no more than that. If you want to store a full text, then we're going to use something else that's not a primitive, and I'll get to that later. So the other and the last primitive type that we have is a conditional. It's a Boolean. What's a boolean? That's a type of variable that has only two possible values. It's either true or false. So you're always going to use boolean variables to store values that just represent like a yes or no information. So if you want to know if someone is underage, for example, there is only two options, right? It's either true or false. So they are underage or they're not underage. It's simple. So for those kind of variables, we can use a boolean. So now let's set some more variables for this person. Remember that I told you that the char is responsible for storing a character, right? So if I wanna set the name of this person, I can't do this, for example, right? This doesn't work because the character, it's only one. So that'll be it. So let's change from name to initial. If I want to store the whole name, then we need something else. Then there are no primitive types that can store there. There are other types of variables that we can create. That is instance of objects. So we have one object that is probably the most used in Java. It's called string. So string name equals John, for example. Now we can see it works. Also, let's add another one, boolean. Let's call this underage equals false. Oh, there's a typo here. So what do we have here? We have the age. Let's fix this, right? We don't want this. We can use short, for example. Remember what we talked. We can use integer, we can use long, but we are going to use a short because that's more than enough for what we need. Yeah, so let's call this initials. So we have a char called initials. String name equals John. Boolean underage equals false, because if he is 25 years old, he's not underaged. Now, just to see if everything works as expected, we can print everything. Initial is initials. Your name is name. You under 8. And then we add underage. In fact, it's quite common for booleans to have this, so is underage, because that makes more sense, right? So is underage true or false? You can also see the code conventions that I'm using. Do you see that I use lowercase for everything? But for this one we have a uppercase here and uppercase here. Why is that? That's how the Java convention works. So variable names should always use lowercase text. If the variable name is composed of more than one word, then you create just the first character as an upper. So in this case is underage. Never do like this, for example. Will this be a problem? Like, will this break the compiler? No, it will work as expected, but it's just not how Java developers write it. So that's the beauty about code conventions, right? If you're working in a company right now and everybody writes like this, and every Java developer learns how to do this, when you go to your next job, everything will still be like this. So this is Java convention. That's how we should use it. So you see that now it says it's red because, hey, cannot resolve it because we changed the name. So it's called now is underage. Yes. Let's run this and let's see what happens. Okay. So it says your age is 25, your initial is J, your name is John. Oh, I forgot an A here. Yes, let's run again. Are you underaged? False. Nice. So this is just a very small example of how can you use all those primitive types in Java. So short, char, boolean, string. This is not a primitive, but this is a object. I'll go deeper into objects and what does that mean a little bit later, but right now I just want to show the basics and see how this works. Okay, and this is a very straightforward. We're just declaring our variables and we are using this to print on the console. I'm pretty sure that we can make this better. So for example, what if I change this to 15 and I run again? What does it say? Are you underaged? False. No, it is true, right? Because now I changed it to 15. So how can I make this variable change if I change this? How can we do that? Java has statements that we can test if a condition is either true or false. For example, we can say we need to check the age, right? So I will say if age less than 18 is underage equals true, else is underage equals false. Let's try to run our software again. So before it was print as false. If I run now, are you underage? True. Okay. Let's put 25 again and let's run. Are you underaged? False. So with this simple statement, this is how we can check any kind of conditions. There are many conditional symbols that we can use it. So this means less than 18. This means less equals 18. Let's try that. So if I add 18 here and I play again, it says, are you underage? It's true, but that's wrong. Because here it says if you are less or equals 18. And in this case, that's not true. We want less or equals 17. Or the smarter way to do that is just keep age less than 18. Then we get the correct result. You can see that the nomenclature for that, we always use if, then you open parentheses, and here is your condition. If that condition is true, the first statement is used. If that condition is false, it goes to else, and then this one is used. This is the basic way to do an if statement. As you can see, it has some complaints here. It says, hey, variable is already assigned to this value. So what we can do in this case is we can always say it's false and we remove this. Because think about it. If age lower than 18, set this to true. But if it's above 18, this block, this part is the line 11. This will not be executed. If it's not executed, underage will always be false. So if we run, we see we have a false. And if I put 15, then it says true. So we can see that our if statement works. Talk a little bit more about the string class. String is one of the most used ones because basically any kind of text that you're going to use it to store, you're going to store that in a string. And the difference from an object to all the primitive types is that an object has methods. Remember that I told you that like, this is your class and this is your method. So if you create an instance of this, that you have that object, and that object has the methods. The same way that string has methods. So for example, let's say I want to get the initial of this name. So what can I do here? I'm going to delete the initials because I want these initials to be dynamic. When I change this, the initial change. So what I'm going to do, so bear in mind with me, what I'm going to do is name, and name is a string, right? When I hit a dot, it will show me all the possible options that I have for that. There is one specific method that is called substring. What does substring do? That method will select some characters of this string. And the way that you have to do is to say which index do you want it to start and which index do you want to finish. We have 1, 2, 3, 4, right? What's the one that I want? I only want the first one. One very important thing to bear in mind in Java. this is a comment, okay? So everything that you put here will not be compiled. It's not a problem. So important Java index always start at 0. What does that mean? That means that if I only want this one, I shouldn't do this, because this is going to say, hey, get the first character. So it starts in the first character and end on the second character. So let's run this and see what happens. Your initial is O. So you got a second one. Why? Because the index always starts at 0. So in this case, I say 0 and 1. If we hit play, your initial is J. Perfect. So we have one less variable here. And we are using a method of the string class to do that. So don't forget, substring is always first index and last index. The last index is not inclusive. So if you want to take the first and the second, so J and O, for example, then you need to use 0 and 2, because it's going to get the 0 index, the 1 index, and it will stop at the second. So remember, index at 0, index at 1, index at 2. Oops. Index at 2. So if I run this, what do I get here? If I have a 0 and 2, I get a J-O. Let's get back this. So your initial is J. Nice. Maybe you can even make this better, right? Think about it. This is a Boolean condition, right? This will always be either true or false. If what I need here is the result of this, so if this is true, under aged equals true. If this is false, it will keep as false. Seems redundant, doesn't it? What if we delete this? We delete the under age. We don't need that. And instead of using a variable, we just put the condition that we want here. So we remove the is under age, and we're going to add the same condition that we use in our if statement. I'm going to do something, and we're going to get a completion error. Take a look. So what was our condition? Age age less than 18. But do you see we get an error? Why do we get an error? Operator cannot be applied to string. The thing is, when you are using those kind of expressions inside, and you're concatenating that with the string, so you are merging this with that, you have to add an extra parenthesis. Then it works. So if we run this, are you underage? True. If I change this to 25, then it's false. So you see what we did? We had 4 variables. Now we only have 2. And with those 2, we can print 4 different information, because we are starting to using methods and operations to do what we want. I would like to explain you a little bit more about the string class. So let's delete everything that we have here. This. I want to show you some methods that are quite common used on the string class. So let's say that I want to print this name as a uppercase. How do you do that? Because the J is already uppercase, but not the other ones. If you just type name dot to uppercase, and then you hit play, John, you see? And of course, the same works for true lowercase. You don't necessarily need true to put any parameter here. So you see John and John. So you already know how to get just one character. You know how to make it uppercase, lowercase. Okay, so now let's change name to Leonardo. I don't know how to write that. Leonardo, yes. Let's say I want to replace a few characters in that. So I can do this. Name dot replace all. So I have to put which character or parts of that string I want to be replaced. So I want to replace all the O's through asterisk, for example. Let's play that. You see? So now we changed everything. It doesn't have to be only one character. It can be more than one. So if I just type AON, so LE asterisk, and you see that the latest one was not replaced. Why? Because now we are searching for ON, and the only place we have ON is in this part. Another thing we can use a lot, so we can check if is there any part of one specific string inside that string. So if I type name dot contains, so if this contains Leon, for example, let's run. It says true because it does. Leon. What if I type this? Instead of the capital L, I'll put the small l. It will say false. Why? In Java, every time you're comparing string contents, you always use the case sensitive. So this is different than this in the eyes of the compiler. How can we work that around? Let me remove everything. I want to check if name dot equals Leonardo. Then I'm going to print name is correct, for example. So with the if statements, we are checking if this is true. If this is true, something's going to be printed. Let's run. Name is correct. But if I change the name to a lowercase l and play, nothing gets printed. Why? Because this is false. How can we fix this? Two ways. We can do name dot to lowercase that we just talked about dot equals Leonardo. So if I run now, name is correct. Let's change this to uppercase. Run. Name is correct because it doesn't matter how it's written here. I can do it like this. It doesn't matter because it will be converted to lowercase and then it will be compared to this. But there's even a better way. The equals method has another method that's quite similar, that's called equals ignore case. Let's run. Name's correct. So what this condition do is, it doesn't matter if it's uppercase or lowercase. When you use this method, it's going to ignore the case. So it doesn't matter if it's uppercase or lowercase, it will always compare both of them as the same. And then it can print for us. If you check the string methods, they have so much more. So we talked about the equals ignore case, substring, to lowercase. There's get bytes, we didn't talk about that. Char at, we didn't talk about that. Concat, contains, we did talked about. Ends with, index of, is blank, is empty. There are so many methods. Maybe just a simple one. It's also a nice one. Let's remove this. I want to check if my string ends with, and I'll add this do. If this is true, let's type correct. Correct. But what if I change here? It's not going to print because now we change it how the name ends with. We also have the starts with. So there's a lot of methods that we can play around, but probably those are the most common methods of the string class.
My initial plan was to cover more topics in this video, but as you can see, it's already too long. I don't want to make like half an hour, 1 hour videos. That would be too much. I prefer to slice into small videos. So for the next video, we are going to talk about arrays and collections. That's a big topic in Java. And after that, we're going to talk a little bit more of an overview of object-oriented programming and exactly what are those public, void, and methods and classes, what every of that means. Okay? That's it for now. Get your study, and I'll see you next time.